determine whether this series converges or diverges? So the answer is it diverges, but let's think about exactly why that is. Well, we're going to use the comparison test. And we want to compare this series to the series where the terms are 1 over n. Now, why is that the series that comes to mind? First, we know that the series of 1 over n, sum it as n goes to infinity, that diverges. Moreover, we think 1 over n because you can fact out the n within the denominator, and you're left with 1 over n times 1 over 1 plus cosine squared n. Now, this is something we can work with. The trig functions like sine and cosine are bounded, meaning they don't diverge to infinity. Moreover, we know two things about cosine. One, we know that it's bounded by -1 and 1, but more importantly, its absolute value would always be between 0 and 1. Now, this means that if you square it, it will also be between 0 and 1 if you square, both sides. This results in the denominator that we have shown, 1 plus cosine squared n, that will always be bounded by 1 and 2 because you just add 1 to both sides of the inequality. Now, since we want it to diverge, we want this, what's shown in purple here, we want this to be larger than something that diverges. To show that this diverges, we want to show that it's larger than something that diverges. So we want to show that it is greater than 1 to the n times some scalar. Because we know that 1 plus cosine squared over n is bounded by 1 and 2, we just want to take the largest possible denominator, and that would be 2. So that's why this would be greater than 1 over 2 to the 2n. Thus, we have the following argument. This inequality in purple is given by our argument up here. So we know that 1 over 2, this series is less than this one if you just look at the terms. And we know we can just pull out half from each term, and thus we have this series on the left. Now, since the series of 1 over n diverges, and if you multiply some series that diverges by a constant, it still diverges unless that constant is 0. It follows from the comparison test that the series in question diverges. Again, this is kind of the main argument of this question, and the argument that allows for the purple inequality is given above.